Hey mathematicians, in this video we're going to talk about some special relationships that are formed when certain angles are made. And the key idea that you have to make sure you keep straight is that these relationships are only true if you have parallel lines, like I do here, that are cut by a transversal. And that's that line, that blue line that is cutting across the green lines. So unless the lines are parallel and are cut by a transversal, these relationships do not hold true. And so the first special type of relationship we're going to talk about is corresponding angles. So you'll notice that you have like two sets of angles. You've got angles 1 through 4 that are all kind of grouped together in the top. And then you have 6 through 8 that are grouped together in the bottom. So corresponding angles are those angles that, for lack of a better term, kind of like match up. They like go together. So for example, 1 and 5 are both located in the top right-hand corner of each group. So that means that they're corresponding. And because they're corresponding, that means that angle M is congruent. So that is a congruent symbol to angle 5. So the congruent symbol for math is, again, an equal sign with this little like curvy Q kind of thing on top of it. Sorry, we're doing a little construction here. So angles 1 and 5 are corresponding because they're in like the same spot of each group of angles. 1 is in the top right, and then 5 is also in the top right corner of the bottom set of angles. So using that same logic, angle 2 and angle 6 are also corresponding angles because 2 is in the top left-hand corner of that top group of angles, and 6 is in the top left-hand corner of the bottom group of angles. So you guessed it, that means that angle 6 and angle 2 are also congruent. And I wrote the 6 first, not sure why, but it doesn't matter. It means the same thing whether I do 6 or 2 first, doesn't matter. So using that logic, that means that angle 3 and angle 8 are also corresponding because they are both in the bottom left-hand corner of each set of angles. And finally, angle 4 and angle 7 are corresponding because they're both in the bottom right-hand corner of each group of angles. So again, corresponding are just the angles that are in the same spot that kind of like match up in each set of angles, and they are always congruent as long as it's parallel lines that are cut by a transversal. So for our next group, we've got alternate interior angles. So all of these angles that are in between the two parallel lines are interior angles, and they're interior because they're inside the parallel lines. And then they're alternate interior angles if they're on opposite sides of the transversal. So what I mean by that is that angle 4 and angle 6 are alternate interior angles. And again, the reason for that is because they're on opposite sides of the transversal, but they're in between the parallel lines as well. And alternate interior angles are congruent. So that means that 4 and 6 are congruent to each other. And using that logic, that means that 5 and 3 are congruent to each other because they are also alternate interior angles because they are inside the parallel lines and they're on opposite sides of the transversal. Just like interior angles, we also have a set of exterior angles, and those are the angles that are outside of the parallel lines. And I'll bet you can see where we're going with this. Alternate exterior means that they are on opposite sides of the transversal. So angle 1 and angle 8 are alternate exterior angles, and they're also congruent. They're on opposite sides of the transversal, and they're outside of the parallel lines. And you guessed it, friends, Angle 2 is congruent to angle 7 because, again, they are outside of the parallel lines and they are on opposite sides of the transversals. They are alternate exterior. Next, we're going to go back to those interior angles and the angles that are in between the parallel lines. But instead of alternate interior, now we're going to look at the same side interior. So for example, 3 and 6. And same side interior have a different relationship. So the measure of angle 3 plus the measure of angle 6 always equals 180 degrees. So instead of them being congruent like our alternate interior, instead they are supplementary. Remember, that's the big kid word for adding up to 180 degrees. And because 3 and 6 are alternate interior, or I'm sorry, same side interior, same logic applies here. Your angle 4 and your angle 5 also add up to 180 degrees and are therefore supplementary. And finally, friends, you probably can see where we're going with this too. So I'm going to look at my exterior angles, but I'm going to look at my same side exterior angles. And the same relationship is true. So the measure of angle 1 plus the measure of angle 7, once again, equals 180 degrees because they are same side exterior, and which means that they're supplementary. And the same relationship applies to angle 2 and angle 8. If you add them together, you also get 180 degrees, which means that these are always supplementary as well. And there you have it, mathematicians. Those are all of the important angle relationships that happen. It'd help if I could get this word supplementary written here. So these are all the important angle measurements that occur whenever you have, again, the most important piece is that these only happen when you've got parallel lines that are cut by a transversal.